Okay, and so in order to talk about relations, we're going to talk about a coordinate system. Now, a coordinate system is formed by the intersection of two number lines, and that's called the horizontal axis and the vertical axis. Remember, we named the horizontal axis using the x, okay, and we named the vertical axis, oops, let's use something a little lighter. Horizontal axis using the x and the vertical axis with the y. Okay, and then we also have a special point called the origin, and the origin is located at the point 0, 0, and that's where the two axes intersect. And so how we plot points, remember how we plot points? If I was going to plot the point 2, 3, remember I always do what first? The 2. And so I always do my first term first, and that goes on the x-axis. So if I was going to plot the point 2, 3, I would start here at the origin, and I would go over 2, and then what about the 3? Where's that 3 going to go? Up 3. So there's the point 2, 3. So remember, you can also do negatives as well. The negatives just mean here are the negatives on the x, and here are the negatives on the y. Alrighty, so let's go ahead and talk about these things. And I don't know if you necessarily need to write all these down, because you probably already know these. An ordered pair is a set of numbers or coordinates written in the form x comma y, which is what we just talked about. The x value is called the x-coordinate. That represents the horizontal placement, and the y value represents the vertical placement. Now, when we put a bunch of ordered pairs together, we call that a relation. So any set of ordered pairs, it could be 2 pairs, 3 pairs, 4 pairs, that represents a relation. Now, we can do a relation in several ways. We can do an equation, we can do a graph, we can do a table, or we can use a mapping. And so down here we have what's known as a mapping. Okay? And that shows how each element of the domain is paired with an element in the range. The set of the first numbers of the ordered pair is the domain. What else is about the first numbers in the ordered pair? What else do we know they're called? When we're thinking of an ordered pair, those first numbers, those refer to the what values? What were you going to say? X values, that's exactly right. That's what I was looking for. So that refers to your x values. What about the range? What is that? That's going to be the y. So basically, these are your x's and these are your y's. And we call those the domain. And we call the y the range. So let's look at how this mapping represented the relation. First ordered pair is negative 2, 4. So I'm going to put negative 2 in the domain, and I'm going to put 4 in the range. And then I'm just going to draw an arrow to them. Okay. Next one is negative 1, 4. So I'm going to put a negative 1, and I don't have to put a second 4 because there's already 1 there. So I'm just going to draw the arrow over to the 4. 0, 6, I'm going to put a 0 here, put a 6 here, just draw an arrow. So that's how you create a mapping. Pretty easy. Shouldn't be that difficult. So let's go ahead and look at all these just so we kind of know. We represent relations using ordered pairs. We can handle that. We represent them using a table, which is similar to the mapping we just looked at, except for here's our x's, here's our y's. We represent it using a graph and then a mapping. Now a little bit about the domain, and we talked about this briefly on the other slide. The domain is nothing more than the x values. So if you want to list the domain, it's just all of the x's. So basically, that goes down here, or that goes down here, or, let's squeeze in those, that goes down here. So that's how you find the domain. It's just the first coordinates. The range, on the other hand, is the y values. So the y values here, the y values here. That's where the range comes from. So if they ask you to list the domain and the range, it's not too bad at all. So let's go ahead and look at an example. It says express 2, 5, negative 2, 3, 5, negative 2, negative 1, negative 2 as a table, graph, and a mapping. The reason we don't have to express it as ordered pairs is it's already ordered pairs. Okay? Determine the domain and the range. So we're going to start first of all with the table. So here's my table, x, y. That's it. That's all you have to do for a table. Now what we need to do is just list. What are my x's going to be? 2. Yep. 5. -1. Need to make it bigger. What goes with the 2? 5. Yep. Yep. Now, and -2. That's all you have to do. Okay. Not too bad. Think you can handle that? Okay. Next, a graph. So if you want, you can use graph paper. Otherwise, you can just do exactly what I'm doing. Okay, so all we're going to do is plot points. So from the origin, where do I go to plot the first point? Yep. So tell me how where I should move my pen. Right? How many? 2, and then what? Up 5. Okay, so there's my first point. What else do I need to do for my next one? Left 2? Up 3. Good. Next point. Right 5? Down 2. Okay, next one. Yep. There you go. So there you go, that's the graph. Biggest thing you need to make sure is that you draw the coordinate plane in with your x and your y's. And then now as a mapping. So as a mapping, for some reason when people do this, they get kind of confused. It's nothing more than the table. So all I'm going to do in the mapping is I'm going to start with 2 circles. Okay? In the first circle, I'm going to put 2. What else? Yep. Yep. Okay. Now, what is 2 paired up with? 5. So I'm going to do this. Put an arrow. Okay. What is -2 paired up with? And I'm going to put an arrow. What is -2? Sorry, I just told you. 5's paired up with -2. Okay. What do I do with the last one? Yep, I just draw an arrow up here because it's the same value. So that's it. Now it says determine the domain and the range of the relation. Okay, so let's focus on our domain and our range. Now if you remember on the page before, we had these little squiggles. And that's what I need you to put. Okay, because that means the set of numbers. So what is our domain going to be? Good, keep going. Yep. Yep. Good job. What about our range? Yep. Yes. -2. 5, 3, -2. And so that's it. That's all you have to do for your domain and range and for the table, the graph, and the mapping. Questions? Okay, so do you think we need to look at another one of those, or do you think you've got it down? Okay, let's go on to the next one then. So we're going to now talk about independent and dependent variables. Now when I think about an independent variable, let's think about the word independent. What does it mean if you are independent? You like separated by yourself. You maybe like to do things on your own. Okay, you don't maybe rely on anybody else. If you're a dependent person, what that means is that you usually do things with others. You depend on them. Okay, and so that's the same with an independent variable and a dependent variable. An independent variable is the value of the variable that determines the output. So it's the one that you plug in. The dependent variable, on the other hand, depends on the value of this independent variable. So it says identify the independent and dependent variables for each relation. The dance committee is selling tickets to the fall ball. The more tickets that they sell, the greater the amount of money they can spend for decorations. Okay, so we have to identify, first of all, 2 variables. So what are 2 unknowns in here? The first unknown would maybe be the number of tickets that they sell, right? What would be another unknown? The amount of money for decorations. Good job. So now I have to identify which one's independent, which one's dependent. So which of those, the number of tickets they sell and the amount of money they have for decorations, which of those, it doesn't matter. It doesn't matter on the other one. Which of those is independent of the two? Tickets, right. So tickets sold. The dependent one, on the other hand, then, is the money for decorations. Okay. Let's look at the next one. Generally, the average price of going to the movies has steadily increased over time. So let's think about that, because this is a little tougher. What is one variable in this problem? Price of the movies, okay? The other variable, I'm going to give you a hint, is actually the time. Okay, the time that's elapsed. So what's the independent variable? The time. And then what's the dependent variable? The price. Because it does depend on time, it's increased. That's what the price of the movies has increased. Okay, that one, like I said, is a little bit tougher, but. Okay, so let's look at this one. This is one of those that when you take your ACT and when you take like some of your standardized tests, they ask you to interpret graphs. Okay, and so that's what we're doing right here. It says the graph represents the distance that Francesca has ridden on her bike. Describe what happens in the graph. So time is this way. Distance is this way. So tell me what ends up happening.
She went farther and stopped for a while.
So basically what ended up happening was she rode her bike, probably to like the park, right? And that's what this part of the graph tells us. Okay, because as time went on, she increased her distance. Then all of a sudden she didn't go anywhere. She stayed put, so she was probably playing at the park, right? Parked her bike, or she's visiting with a friend, she's at a friend's house. And then what ends up happening here? Yep, she's pedaling her bike again. So all you would have to do is put that into words. Okay, let's look at this next one, driving to school. Okay, so let's go ahead and put this into words. What are we doing here? What did we do here, from here to here? What? You drove where? Maybe to Casey's? What did you do here? Stopped and had to get breakfast. Okay, then what'd you do here? Yep, you're not going as fast though. So you're going a little slower, probably because you're eating your food. Okay, or you got behind somebody that's slow. Then what do you do here? Stop again. Maybe ran into construction, something like that, where you had to stop, and then all of a sudden, you're going again. Okay. All right, let's look about time and income here. All right, what happens here? Yeah, you're making some money, right? You're making money. You're making, decent. What are you doing right here then? Yeah, you're increasing, so you're making a lot of money in not a lot of time. Okay, because you made that sharp jump. Here again, you're making money again. What happens here? Yeah, you're just not making any money. Okay, just kind of staying steady. And then this one, you're starting to make money again. So that's what you're going to need to do. Questions? Interpreting graphs. So this is what you need to do on pages 43 and 44. I need you to do 10 through 31. And you have the rest of the time to work. I would probably expect a quiz Tuesday, Wednesday of next week. Okay? So